Did you know that a flock of 10,000 chickens produces a daily soundscape that is literally as complex as a symphony? It's wild to think about. And in today's Explainer, we're diving into a truly revolutionary framework mapped out by veterinary specialist Dr. Ali Majid Hamid. We're breaking down his groundbreaking work, Poultry Vocal Language, this scientific map. Because you see, this isn't just about hearing birds chirp. It's an entirely new paradigm for diagnosing poultry health by analyzing sound, behavior, and environment all at the same time. So let's just dive right into this.
I want to kick things off by having you ask yourself a pretty profound question. What if you didn't have to wait for a bird to actually look sick to know that it was? Just imagine a proactive world where auditory clues pop up way before physical illness ever sets in. For decades, veterinary science in poultry has been super reliant on visual cues, right? Waiting to see clinical signs, or honestly worse, waiting for mortality rates to spike. But here's the thing, sound travels faster than physical symptoms manifest.
And that realization represents a massive paradigm shift. Think about traditional diagnosis. It's fundamentally reactive. You do visual inspections, you spot a sick bird, you react to it. Flock listening medicine, on the other hand, is highly proactive. It's the science of detecting continuous auditory signals and spotting deviations from a baseline long before you ever see a single physical symptom. It completely transforms the veterinarian from a reactive responder into a proactive listener.
So, here is our roadmap for today. We'll start with the birth of flock listening, move on to the customized baseline, break down the FLACKER protocol, look at the sound diary, and then wrap things up with AI early warning.
Okay, Section 1. The birth of flock listening medicine.
The absolute crucial point here boils down to this core metaphor. The flock has to be treated as a single, collective biological organism. In traditional medicine, we might zero in on one individual bird's cough. But flock listening medicine says, no, zoom out. You have to listen to the flock collectively. The flock is operating as this incredibly synchronized biological system, sending out continuous, real-time signals about its health, its production, and its environment through the noise it generates as a whole.
Which brings us to the central equation of this entire methodology. You see, sound is never analyzed alone, like ever. It's a multivariate equation. A clinical decision only comes from taking sound as your primary input, and then combining it with behavior, stuff like crowding or lethargy, plus production metrics like feed intake, plus the environment in epidemiology. You literally cannot diagnose effectively without all of these puzzle pieces working together.
Moving on to Section 2, the customized acoustic baseline. Now this is a seriously foundational concept. The flock acoustic baseline is defined as a specific natural sound measurement that is totally unique to a particular flock. Dr. Hamid makes a great point here. Asking, what does this disease sound like, is actually scientifically flawed. There's no universal one-to-one sound for a disease. Instead, the vet has to ask, what is the normal acoustic baseline for this exact flock right here, right now? You have to know exactly what normal sounds like before you can even begin to detect what's abnormal. And what's really fascinating is realizing just how dynamic this baseline is. I mean, it is constantly shifting. A flock's acoustic baseline is fundamentally altered by things like the bird's age, specific breed variations, environmental conditions, daily temperature and humidity swings, and even flock density. So, a normal sound for a young flock in high humidity, that's going to be completely different from an older flock in a dry environment. The baseline isn't static, it's a living, breathing metric.
All right, Section 3. Comprehensive Field Diagnostic Protocol.
Here, Dr. Hamid introduces the FLOCKR protocol. Think of this as an 8-pillar diagnostic toolkit specifically designed to prevent diagnostic deception out on the farm. FLOCKR breaks down into flock baseline, location of the sound, onset like when did it actually start, context, key signs accompanying it, environment, age of the birds, and their response to stimuli. By systematically checking off these 8 pillars, a veterinarian makes sure they aren't just reacting to a random noise, but really thoroughly diagnosing the whole situation. Let's look at how a vet actually applies this framework in the real world. Instead of just jumping to conclusions, they ask highly structured questions. Is the acoustic change sudden, or has it been gradual? Does it affect the entire flock, or is it isolated to just one little corner of one barn? Does it coincide with a sudden drop in water intake? It's this structured inquiry that takes mere listening and transforms it into true clinical diagnostics. Which leads us to Section 4, the flock sound diary.
Because, let's face it, memory just isn't enough when you're tracking these incredibly subtle biological shifts.
Trying to remember if a cough started before or after the humidity spiked in a barn of 20,000 birds? Yeah, that's impossible. So the Flock Sound Diary steps in as a unified recording tool linking acoustic data directly to environmental and production metrics over time. It essentially acts as a chronological anchor. You aren't just jotting down heard coughing today. You are logging that exact sound alongside the specific temperature, the humidity levels, the ammonia concentration, and the feed consumption for that exact hour.
And here is exactly why that diary is so incredibly powerful. Cross-referencing these inputs reveals hidden patterns way before obvious clinical signs occur. For instance, if you notice a sudden silence in the flock and cross-reference it, you might find it aligns perfectly with a temperature drop and decreased water intake. Or maybe you notice increased collective panting, and that correlates directly with a spike in high ammonia levels, which is leading to feed reduction. The diary connects the dots that visual inspection alone completely misses.
Now for the tech side. Section 5. AI for early warning.
To actually automate all this listening, we use an AI sound pipeline. It kicks off with raw audio capture from microphones set up in the barn. But AI doesn't just listen the way you and I do, right? It transforms sound into data. Step 2 is feature extraction, which often means creating a MEL spectrogram, basically a visual representation of the sound frequencies. Step 3 involves machine or deep learning models analyzing those specific patterns against our customized baseline. And finally, Step 4 spits out actionable alerts. It really is an incredible journey from chaotic, noisy barn audio to precise medical insight.
Dr. Hamid outlines the Avane Prima early warning system, which neatly categorizes these AI alerts into 4 distinct tiers: normal, watch, alert, and critical. Now, I want to emphasize a really crucial point here. This system acts as a decision support tool. It is absolutely 100% not a replacement for the veterinarian. Instead, think of it as a tireless assistant that taps the vet on the shoulder and says, "Hey, something just shifted from the baseline in barn 3, you should probably go investigate."
Now, what's really cool is where this AI actually lives, because sending massive audio files to the cloud, that takes time, and it relies on having perfect internet, which, let's be honest, farms rarely have. That's where technologies like Edge AI and TinyML come in. They allow all this complex processing to happen instantaneously, right on a tiny chip directly inside the barn. No cloud delays, no internet dependencies, just real-time processing for real-time biological monitoring.
But hey, we've got to stay grounded here. Maintaining scientific objectivity is paramount, and the source material strictly warns against some critical pitfalls we have to watch out for. We have to navigate biological deception, like a flock sounding distressed simply because of temporary fear, not an actual disease. We also face technical illusions like dataset bias or domain shifts. For example, an AI model trained perfectly on a farm in Europe might fail completely when it's deployed on a farm with totally different acoustics in the Middle East. So while the technology is incredibly powerful, it demands rigorous validation.
As we wrap up this explainer, I really want to leave you with a fascinating question to chew on. What is the ultimate future of listening in veterinary science? Like, where exactly does agricultural tech go from this acoustic baseline? Well, the answer lies in a multimodal AI future. Audio is just the beginning, folks. The future merges this continuous acoustic monitoring seamlessly with real-time thermal imaging to detect fevers, video behavior analysis to track how the flock distributes itself, and automated water consumption tracking. By layering all these sensory inputs together, the AI gains a complete 360-degree understanding of the flock's health at any given millisecond.
And that brings us to our final, highly provocative thought. By combining the Flock.Your protocol, the customized acoustic baseline, and multimodal AI, we are literally stepping into the era of digital twins. We are no longer just farming, we are creating a real-time, virtual replica of the flock's entire biological state right on a screen. Think about that for a second. If you can perfectly mirror a living organism's health digitally through sound and data, what diseases could we prevent before they ever truly begin? It's a profoundly exciting frontier in digital animal welfare, and I really hope this explainer has sparked your curiosity to go out and learn more.